Hello there, everyone. In this module, we're going to be learning a little bit about basic surveying techniques. And so what I've got here is a pretty simple survey setup. I've got a tripod below, which you've probably all seen set up in the past. And on top of that, I've got the actual survey instrument. And this particular survey instrument is very simple. It's something known as an auto level. And essentially what this instrument does is measure a level plane out into the landscape so that you can measure the elevation of points on the ground relative to this level plane. Now, the first thing we have to do when we set up a survey is figure out the elevation of the actual level. So what we need to do is shoot some known point that we have in the landscape. That might be a benchmark or some GPS point that we've collected ourselves, right? And then we shoot that point in order to establish the actual elevation of the survey instrument itself. Once I know the elevation of this instrument, I can rotate it around and I can shoot points in the landscape. We need to have someone off in the distance holding a survey rod to essentially get the measurement between the elevation of the survey level and the ground surface itself that we're shooting. And so using that method, we can get a back sight, establish the elevation of our level, and then we can turn and shoot new points in the landscape to establish the elevation of our surface of interest. All right, so I wanted to quickly show you the actual survey rod that you have to read the measurement from through the survey instrument. So when we're surveying a new point, we look through the eyepiece of the instrument toward the rod in the distance, and then you actually read the elevation, basically the height above the ground level as measured by the auto level. And so in this case, we can see the auto level, if we were surveying this point, would hit somewhere on the rod right around here. Now, a couple things about this rod I want to point out is you'll see some red numbers. The red numbers indicate the number of meters you are above the ground. So here's 1 meter, and you can see the red is showing up because when you're looking through the actual instrument, you only see a small window of the rod. So you want to know that you're okay in the range of 1 meter. The black numbers then indicate every 10 centimeters. And then you'll notice there's some other additional gradations on the rod itself. Sort of this upward facing trapezoid is basically indicating you're right at 1.2 meters, for example, here. And sort of this downward facing trapezoid is every 5 centimeters. And then the black and white alternate every centimeter. So essentially it's just a complicated ruler to measure the elevation of the rod relative to the elevation of the auto level itself. Now that we have the elevation of our level by shooting the back sight, we know the elevation of this level plane. I can shoot to any point in the landscape now, take a measurement on the rod, and that will tell me essentially how far above the land surface is my level plane. And so I simply subtract that rod reading from the elevation of my level height, and that will give me the elevation of the ground surface. And so we can see in the background, we have Jason holding the rod at a point in the stream channel. I'll look through the level here, and I'm able to see that the rod reading is about 2.95 meters, which means that the ground surface there is about 2.95 meters below my level plane. Once I've got that shot, I put those notes into my notebook, and I say I got it, and Jason moves to the next important point in the topography. And so over time, we can build a topographic surface by surveying multiple points, taking those rod readings, subtracting those from the elevation of our level plane, and giving us a nice surveyed cross-section so we can do additional calculations. Just to summarize here now, once we've got our cross-section measurement, we need a couple more pieces of information if we want to do some calculations of discharge or sediment load that might be coming down this channel. The first thing we need is the longitudinal profile or the slope of the river, and we can survey that similarly to how we did the cross-section, except in this case measuring the elevation from upstream to downstream. The second important piece of information we're going to need is the grain size of the sediment on the bed. This affects both the roughness of the flow as well as has an effect on how much sediment might be mobilized by different types of floods. Once we have our cross-section, our slope or longitudinal profile, and the grain size of the sediment on the bed, we have most of the important information we need to do a lot of calculations of things like flow discharge, sediment transport, and have an understanding of how this stream would behave during floods.